Okay, so I'm going to show you what I want us to do with lab number 2, our speed of sound one. We're not going to do a full lab write-up. Taking a look at some of the other stuff, it's going to take me a while to grade the full lab write-up on the others, but I've got something that we can do that should be pretty easy to do overall. It'll give you some experience in making a computer-generated graph and seeing some of the other more powerful things that Excel can do for you with data analysis. Okay? So the first thing that we're going to do is we're going to need to put our data in. So I'm going to type in trial, just like I did before. I'm going to do position 1. So I'm going to do x1. Or I'm sorry, our data's in time, so I'm going to do t1, the time for position 1, and I'm going to mark that it's in seconds. I'm going to skip a column just to have some extra space there in case I want it. t2, the time for position 2, also in seconds. So I'm going to do my 10 trials. I got some data from one of the other students, so I'm going to put that in now. You'll want to use your own data, of course, but this is what we've got for the demonstration. So I'm going to plug these in. This was my data for the first location, which is the nearer of the two, so it should be your set that is a lower value than the others. I'm going to put in the data from location number 2. And I've actually taken a look at this data before. It's surprisingly good. I'm not certain that everyone's is going to turn out even remotely like this, and that's totally fine. We still have a lot of human response time that is going to cover a lot of the results. So I'm going to write down here average, like we've done before. I'm going to do, in this cell, I'm going to hit equals to tell Excel to do some math for me. I could use the function button up here and search for the average function, so I could take the average of a bunch of numbers, but I know that it's just the word average followed by parentheses. I'm going to grab all of those numbers that I want it to average, close my parentheses, and hit enter. I'm going to drag that across with the little square on the bottom right there. And then, since I skipped a column, that's telling me, oh no, it's bad. So I'm just going to get rid of that guy. I'm going to write standard, or stdev down here for my standard deviation, because I like taking a look at those. Standard deviation, I'm going to drag along this. And get rid of that guy. And then finally, I'm going to do something called percent standard deviation, and that's going to be equal to my standard deviation divided by my average. Basically, this is giving me an idea. My standard deviation tells me how much spread there is in my data, and so for the most part, for any of my data points, probably 60% of them fall within 0.05, my standard deviation, of my average 0.23. Okay? So 60% of these, so 6 out of the 10, if not more, fall within 0.05 of 0.231. That's what this number is. It tells me how spread out my data is. Basically, it's a way of measuring the precision. We talked about precision versus accuracy. Precision is getting kind of the same measurement over and over again. If I had incredibly precise data, my standard deviation would basically be 0. So the bigger this number is, the more spread my data is. And so now if I take that spread and I look at the actual size of my full signal, my actual data point, I can see that in this case, for these first ones, my noise, or my spread, how spread out my data points are actually about 1/4 of the total value of that data point. That's actually very noisy. That tells me that these aren't as reliable data points. Whereas if you look later on, I have the same amount of spread, but because I have a much longer time that I'm actually keeping track of, it represents a much smaller amount of it. So these data points are actually probably a lot better than these. That's okay though, we're going to keep all of them and just see what we get. So we've got our data averaged out, and we've done a little bit of data analysis on it. So I'm going to do, over here, I'm going to do time in seconds. And then next to it, I'm going to do x in meters, that's my position. And so my positions were, I had 0, 142, and 246, I believe, for my distances. So this is where I was clapping the board together, which we said if we had someone there actually taking the measurement, they would read 0 seconds, because they would hear the sound at the same time as they see the boards clap together. At 142 meters, well, I'm going to hit equals and tell it to take whatever value is in this square. That's my average. That's my average of all of these data points that I have from position 1. And then I'm going to do the same thing here for position 2. I'm going to put the time in there. Okay? And so now, oops, I clicked the wrong one, didn't I? Helps if I click the right one. I want to use the average, not just one of the data points, so that way I've got an idea. I'm using something that comes from all of my data instead of just one of them. Okay, so the last thing I'm going to do is I'm going to insert a graph. So I'm going to come up here to insert. It might look a little bit different in different versions of Office, but you go up to insert, and you want to find an icon that looks like a bunch of dots on a graph. That's our scatter plot. So I'm going to select that. And we'll go ahead and do this, which is straight lines connecting them. I'm going to bring it over here. Okay. And then I'm going to have you do something a little strange. I want you to left click on your line, on your little dots there. That's your data series. You'll right click. And we're going to use a function called add trendline. And it's going to bring up something. It has different boxes depending on which version you're using, but we want to make certain that linear is checked. That says basically what a trend line is going to do is it's going to say, okay, average out all of my data and give me one straight line that describes all of my data. Okay? And so it'll be a little above the low data points, as you can see here. It's a little above that, and it'll be below my data points that are too high. So it gives me a good average of everything. The final thing that I want to do is back over here in the trend line box, I want to set this option, display equation on chart. That's going to help us out a lot. Okay, that makes an equation for the line come up. I'm going to drag it up here where I can see it a bit more clearly. I'm going to come up here, and if I left click there, I can change the name of it. I'm going to do position versus time, because this is a position versus time graph. Now, as you may recall, and if you don't, you want to review it because we'll be having a test over this material soon, but I can tell a velocity from my position versus time graph by looking at the slope. Well, I've got this trend line that actually describes all of my data put together, which is good, so it's got a nice average going on, and I told it to put my equation up on the chart by itself. And so I've got y equals mx plus b. Well, m is my slope, so that number right there, 354, is my slope. Well, this is in meters, and that's in seconds, so my slope is 354 meters per second. That's very close to my actual speed of sound, which is 343. Okay, so what I want you to do is I want you to follow the steps that we've done here, generate this position versus time graph, and I want you to add that trend line. Okay, rewind if you don't remember how I added it, but you want to add a linear trend line and add the equation on chart so that we can see it. Then you can left click on it and then hold down and left click, and you can drag it wherever you want. Make certain that we can see it all right. Then you'll print this off, you'll put your name and your hour on it and turn that into me, and then that way we'll be able to see what type of results we got for the speed of sound. If you ended up with a slope that's very, very different from the speed of sound, don't worry about it too much. Remember, there was a lot of human error that comes into this, reaction times, and so I'm a little surprised that we had values that came this close. So, I'd like to see what you all get, and this is a nice simple way for you to get that information to me, and also learn a little bit about crunching some numbers and the powerful things that Excel can do for you, not to mention generating nice looking graphs. Okay? All right. If you have any questions, then let me know.